Hi, I'm here to show you how to graph angles onto pi. So first you need to know that this pi is going to represent a unit circle. Unit circle means that it is on both the x and y axis at exactly 1 point each direction. This is the origin 0, 0. This is the x-axis, so thus this would be 1, 0, this would be 0, 1, this would be negative 1, 0, and this would be 0, negative 1. We're going to start graphing angles, except almost everybody knows how to do this. What we don't know is what each of these spots symbolize. This spot right here is the exact same as 2 pi. 2 pi. This spot is equal to pi over 2. This spot right here is equal to pi. And this last spot is equal to 3 pi over 2. Now these angles aren't completely chosen at random, for each of them is actually all over 2. This is 1 pi over 2, because it's the first one up. This is 2 pi over 2, but you simplify down to pi. This is 3 pi over 2, and this is 4 pi over 2, because you simplify down to just 2 pi. Now first, I'm going to show you how to graph a positive angle. To graph positive angles, you go in a counterclockwise manner around there, starting up, because it's positive. Now we'll graph an example, 12 pi over 9. So to do 12 pi over 9, you basically split it into different 9 portions into here. So you would have to split into thirds and then into thirds again. So we'll split pi into thirds, and then we'll split each piece into, there's one here, into thirds. So we have an equivalent 1, 2, 3, 4, 5, 6, 7, 8, 9 parts. So then you have to graph 12 of them because it's 12 pi over 9. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now once you get to this part, you only have 9. So we have to continue on past pi. So you'd have 10, 11, 12. So the angle would be right here, going this way. Now you draw the arrow around the circle to demonstrate that you know that it's a positive angle. Now this angle right here is 12 pi over 9. Now I'm going to show you how to graph a negative angle. You basically graph a negative angle the exact same way, but instead of going up and counterclockwise, you'd go down and clockwise. So you start with the same axes on the unit circle being at origin, except now we'll graph the angle negative 3 pi over 4, just as an example. So, like the same that we did before, we'll split it into the pi part, because right here is pi, into parts. Except what also ends up being different is this is still 2 pi, but now it's negative 2 pi. This is negative pi, this is negative 3 pi over 2, and this is negative pi over 2. Everything is reversed. Normally it would be up there, but now it's down there and all negative. So first, you have to split it into 4 parts because we're graphing negative 3 pi over 4. So this is pi, split into 4 parts would be 1, 2, 3, 4. Now, we just have to graph 3 of them. So you go over 1 line, 2 lines, 3 lines. So your end result would be right here with the angle going downwards because it's a negative angle. Now that you know how to graph angles, I'm going to show you how to find the sine, cosine, and tangent of each of those angles. You start out with the pi again, and cut it into the dividing lines, which should be the unit circle. Then, you pick random angle. I say we should do the negative angle because it ended up so good for us last time. So we'll do negative 3 pi over 4. We'll start graphing negative 2 pi, negative 3 pi over 2, negative pi, and negative pi over 2. Now we'll graph negative 3 pi over 2. Draw your dividing lines because you know that you have to divide it into 4 parts. And then swing the circle around to the third one because it's 3 pi. That's negative 3 pi over 4. Now I'm going to show you how to graph the sine and cosine. You have to make a right angle triangle, so that would be right here. Because if you had made the triangle anywhere else, it wouldn't be right angle. So we know that this is equal to 90. Now you have to find the degrees of the other two sides. So you take 180, which is the line, divided into 4 parts. 180 divided into 2 parts is 90. 90 divided into 2 parts is 45. So we know that that angle is 45. And the angles within a triangle always add up to 180, which makes this angle also 45. Now it gets a little bit more challenging. Now we have to graph to find the cosine sides, so we have to find the sides of each of these angles. We know that since it's on a unit circle, any of the points on the crest would be equal to 1, just like I showed you earlier. And what you learned in basic geometry is that when these sides are equal to 1, this would be 1 and the rad 2. Thus you would have to divide 1 by rad 2 to get each and every other side. Rad 2. That's the same as the square root of 2. That's what would break. 1 rad 2. So now you know the lengths of each side, except you have to find the sine, cosine, and tangent of them. You have to remember this simple thing called Sohcahtoa. So, Sohcahtoa. Sohcahtoa. That's how you remember which sides you use to graph and when you're using sine, cosine, and tangent. When using sine, you use the opposite side over the hypotenuse. When graphing cosine, you use the adjacent side over the hypotenuse. And when you're graphing for tangent, you use the opposite side over adjacent. Now, how do you know which sides are which? Well, you always graph at the angle that's in the center. Opposite would be the side that's opposite of the angle, so it would be this side. Hypotenuse is always the longest side across from the top of the triangle, which is this side, and then adjacent is the one that touches on to the angle. So, for sine, you would have to graph opposite over hypotenuse, which should be 1 over radical 2 over 1. Anything over 1 is just what it originally is on top. So that means sine is equal to 1 over rad 2. 1 over rad 2. Now we do it for cosine. Cosine is adjacent over hypotenuse, so that would also be 1 over rad 2 over 1. That is just the same, so it would also be 1 over rad 2, because anything over 1 is that. Last but not least, you graph tangent, which is opposite over adjacent. This gets a little more challenging because it's 1 over rad 2 over 1 over rad 2. But when you divide it like that, it's the exact same as multiplying. So you would be basically multiplying 1 over rad 2 times rad 2 over 1. Now, you can cross cancel because you know that those are equal to the same thing. So in the end, I believe you just get 1. I might be wrong. Go. So, in the end, you get for sine 1 over rad 2, cosine 1 over rad 2, and tangent 1. But there's one last step. Because it's south of the equator, as we'll call it, or south of the x-axis, this point would be negative 1/2. This only affects the opposite, which should make sine negative 1 over rad 2. Even though the unit circle line is below it, you never have the unit circle as a negative. Wherever the hypotenuse is on pi, it's always equal to positive 1. Also, since the adjacent side is below the x-axis, it would make that a negative 1 over rad 2 as well, making the cosine negative 1 over rad 2. In the end, when multiplying negative 1 over rad 2 times negative rad 2 over 1, you'd still get just 1. So everything works out with cosine and sine both being -1 over rad 2 and tangent being 1.